Hello, good evening, all of you. Very good evening. If I am audible, please tell. I am audible. My voice is clear to everyone. Please put your message if I am audible. Hello. Very good evening, Chandana, Lakshmi Priya. Very good evening. Okay, good. If I am audible, Chandana, I am audible better. Very good. Other people also can reply in the chat box if I am audible or not. Jyoti, good evening. Swati, very good evening, beta. Okay, now again I'm introducing myself. My name is Harimohan Singh and I'm your physics mentor and I'm taking care of electrodynamic portion, and we have started from electrostatics. Okay, in electrostatics till now we have seen a few things. Very first thing, what are the charges, charging methods, okay, friction or conduction, or we can say induction. And after that we have started Coulomb's law. In Coulomb's law we have seen the lot of examples. So in the last class I was discussing, this was the last example we have discussed, the pith wall problem, the leakage of charge, and we have seen this is a 2016 NEET question, and already this is a question in IIT JEE Main also, and in Erudov question also. It is originally Erudov question we have seen, and we have discussed this thing, what is the meaning of this dq by dt. If you want to see, this is alpha under root of 9 mg by 8 kl. This is the question, or you can write in this term कि V is inversely proportional to under root x, or V directly proportional to x to the power minus 1 by 2. We have seen this problem. Okay, now using this whole setup we can go for further, and we can see another problem that is also NEET question, NEET 2013 question actually. 2013 question, this we have seen, that is the two pith balls carrying equal charges and suspended from a common point by the string of equal length. The equilibrium separation between them is R. Now the string are rigidly clamped at a half distance. We have seen this is the y by 2. I'm just putting it, you will understand. Just focus. Initially they are equal charges that you have to see. Just wait. Yes, I'm taking a pen. Yes, now you can see their charges from a common point, a string. Their charges, there's some problem is there, I think. Charge. Okay, equal charges, correct. This is equal charges are suspended, and a string of equal length is also equal. It is given to you. Now the equilibrium separation between them is R. Initial separation was R. Initial separation is R. Okay. Okay. Now next is the string are rigidly clamped at a half height. That means you can see here, this is y by 2. Initial it was y. Okay. This is y. This is y by 2. Half distance. The equilibrium separation between the balls becomes, now equilibrium separation, this is the R prime actually. It is the R prime that they are asking what are the value of R prime that we have to calculate. Okay, I'm repeating again, this is y by 2, this is R, and this is R prime. We have to calculate R prime value. Okay, that we have to calculate what is the meaning of R prime beta. Okay, now understand very clearly. What we can say here, again the tan theta term, I'm writing it, you will see the tan theta is equal to Fe by mg. Okay, Fe by mg. But by the way, what is the tan theta in first case? If I am saying this angle is theta beta, this angle is theta here. You can check this angle, I am taking a theta. This is angle also I am taking a theta. Then what you will say? What is tan theta? Tan theta would be this value, perpendicular upon base. Perpendicular upon base, that means r by 2 divided by y. So you can say tan theta is equal to r by 2 divided by y. We can write it. Similarly, in second case, you can assume this angle is suppose alpha, and this angle would be also alpha. So tan alpha would be this perpendicular upon this base. So what you can say, tan alpha. In next time you can write that the tan alpha is equal to Fe prime, because the separation is changed, divide by mg, and that is equal to r prime by 2 divided by y by 2. It is given to you. So from here you can say this is r by 2y, and this become r prime by y. That's the very basic thing, we can write it. Just you can take the ratio. This is equation 1, this is equation 2. If you are taking ratio, what you will get? Equation 2 divided by equation 1. I am taking a ratio. So you will say that this is the Fe prime divided by mg upon Fe upon mg. That is equal to r prime by y is equal to r by y. We are writing it. So from here you can say that is equal to, sir, Fe prime upon Fe is equal to r prime, and there are 2y actually. You can write it that is equal to upon r, but this 2 will go above, that would be 2r prime. Can we see this part? Can we understand this part better? That is Fe prime by Fe. Mg cancelled from here. You can cancel the mg. Y also cancelled. So this becomes 2r prime upon r. Now what you can write? You can write very simple thing. Ki sir, Fe prime is nothing else kq square upon r prime square upon, this would be kq square upon r square. Okay, that is equal to 2r prime upon r. 2r prime upon r. So this is kq square upon r prime square upon kq square upon r square. So what we can do? Kq square cancel. Okay, nothing more than that. What you can write it? You can say very simple. This becomes r square upon r prime square is equal to 2r prime upon r. Very simple thing. You can say r prime cube is equal to r cube by 2. I am writing again. This r prime square going right hand side, this become r prime cube. This 2 is also this side. So r cube by 2 we can write it. So from here that become r prime is equal to r upon 2 to the power 1 by 3. That is the answer of this question. I am repeating again, listen carefully. Initially you are clamping at a height of y. Now this is the height is y by 2. So this was y, this is y by 2. That means theta is going to change with the vertical. If initial we are assuming it theta, then we are saying this is a alpha. The angle changed. So initial you are saying tan theta, then you are writing tan alpha. But the basic nature to write that formula, that tan theta is equal to Fe by mg, that will remain same. This is Fe by mg, this is Fe prime by mg, because mass is not going to change. Fe is changing. Why is Fe changing? Because the separation is changed from here to here. The separation between the pith walls is going to change. If it is changing, you can put it. Initial distance was how much? R by 2. This is y. This distance is beta r by 2. You can write it. Okay, this distance is r by 2 here. If you are putting it, this is r by 2 beta, and this is y. Here this is a r prime by 2, and this is a y by 2. This is r prime by 2. This is r prime by 2. So we can write it r prime by 2 upon y by 2. This become r prime by y. We have take the ratio and we can get the answer. R prime is equal to r upon 2 to the power 1 by 3. Is it clear? Is it clear to everyone? If it is clear, put in the chat box ki yes, it is clear. Then we can move to the next point, next question. Please reply, beta. SMT, Swati, Jyoti, Chandana, Lakshmi, Priya. Everyone, please reply. Please reply. It is clear to everyone. Swati, very good, beta. Purandeshwari, very good. Amala, good. Now, we can move to the next problem. We can see another problem. It is a actually J question, but it is a very similar to what we have learned till now. This is given to you two identical tennis balls. You can take as a pith balls. Each is having mass m, charges q are suspended from the fixed point by threads of length L. So I am putting this length is equal to L, charges are equal. Okay, what is the equilibrium separation between each thread, making a small angle theta with the vertical? Theta is small. Try to see this theta is small. They are asking this question, very simple question we can solve. Okay, so this question we can solve it. How we can write? Very simple. Okay, diagram first we have to make it. This is a diagram, beta. I am making this diagram. You can check. You can try also this question. Take your time, try it. This length is L, it is L. Suppose I am assuming the separation between them is x. This mass is m, charge is q. Mass is m, charge is q. Remember, theta is very small. That means x is also very small as compared to L. Try to understand it. Now we are going to solve this. So we can write from here very simple thing, tan theta first. What is tan theta? Tan theta is equal to Fe by mg. Fe by mg, that is the tan theta. Okay, Fe by mg. And tan theta is also approximately can be written this perpendicular upon this base. Perpendicular x by 2 and this base is equal to L approximately. So this is x by 2 upon L we can write, or you can say x by 2L. We can write it. Clear? Now put the value of Fe. Fe is nothing else k q square divided by x square upon mg is approximately x by 2L. Approximately x by 2L. Now write properly. You can say from here, so this become k q square divided by mg is approximately x cube divided by 2L, or x I want to write, so I am taking all things in left hand side. So this become x cube is equal to 2kl q square divided by mg. Okay, we can write it, or x is equal to, you can say 2kl q square divided by mg to the whole power 1 by 3. This is the answer. This is your answer. If you want to write this k value 1 by 4 pi epsilon naught, you can put it, you will get the answer. I am writing it, you will understand. Okay, you can say, sir, this become x is equal to bracket 2 L q square divided by k value would be 4 pi epsilon naught into mg to the power 1 by 3. This is 2, this is 4, this is cancelled, this becomes 2. So x is equal to, you can write L into q square divided by 2 pi epsilon naught into mg to the power 1 by 3. That is the answer. Any options? You can check it. Q square L approximately everywhere. First two options may be possible, but these two options is cancelled. Okay, next. How much written there? Q square L. This power is 1 by 3. This power is 1 by 2 and 1 by 3. This is also cancelled. Only option is this is correct. This you have to understand it. Directly you can write and you can get the answer. Option B. Everyone is getting, beta? Lakshmi Priya, Prem, Amala, Purandeshwari, Lakshmi, Swati, SMT. Are you getting this question, beta? Understanding how to solve? Yes sir, no sir? Please reply. Please reply, beta. Swati, very good. Other people also put your Lakshmi, very good, beta. Amala, good. Saranya, good. Okay. Now I think we have seen approximately 8-9 questions related to the pith ball problem. So any question comes to you in a paper, any discussion, then you can solve it. I hope everyone is clear about this idea. Yes or no, beta? Now we are going to start the very important point, that is the next topic, that we say electric field and its characteristics. So today we are going to start the new topic, that is the electric field and its characteristics. Now very first question comes to you, okay, sir, what is the meaning of electric field? Why we are studying this topic? Please explain first. Yes, I'm starting this part. Suppose I will say, suppose this pen is I'm having in my hand and I want to apply force on this pen. So how I can apply? I'm taking this pen, I'm just stretching it, or I'm just pushing it. I'm stretching it or I'm pushing it. In any case, my hands, my body is in contact with this pen. That means I have to be in contact, then only I'm able to apply the force on this pen. Okay, very good. This force we call it what? Contact force. This force we call contact force. That means there should be some contact. Without contact, you cannot apply a force from one body to another body in this kind of forces. But there are some other kind of forces also present in the nature. They do not require any contact, just like gravitation is there. In gravitation, we have seen that there are 2-point masses are there. Suppose this mass is m1, this mass is m2 at a distance r. So what is the force acting between them? Directly you can say it's g m1 m2 by r square. This is given by Newton. This is Newton's law of gravitation. Similarly, we have seen in this chapter also in the starting Coulomb's law. This is a q1, q2, this separation is r. So what is the force? Force is equal to, you are writing k q1 q2 by r square. This is also force. But these 2-point charges are not in contact. These 2-point charges are not in contact. Still they are able to apply the force on each other. Still they are able to apply the force on each other. That's why we call this as a field force. This field concept given by actually Michael Faraday. And then still after that, many scientists come forward and they did an experiment on that, and they proved it. Yes, this hypothesis or this theory is good to apply in the electrostatics. Okay. But if we go into detail, what is the meaning of electric field? We have to learn now. We have to understand it. So I'm just telling you a few things. Just focus. So I'm just first removing this part because it is not required in this topic. Okay. Now I'm just starting from very basics of this. Okay, suppose there are 2-point charges. This is q1 and q2. Okay, at separation r. So what is the force acting between them? So you will say the force is equal to 1 by 4 pi epsilon naught q1 q2 by r square. This is the very simple thing, we call it force. We call it force. This I am saying 1 by 4 pi epsilon naught q1 q2 upon r square. That is the force acting between these 2-point charges. Very good. Now understand one more thing I am telling you. How they can apply. So for that I am giving one hypothesis. What is that hypothesis of one theory? Suppose this charge q1 only present here, then this charge is creating its own effect, okay, I'm repeating again. This is a charge q1 is creating its own aura, we can say its own environment in its space, nearby space. If any other charge will come in that surrounding, then it will experience a force, an electrostatic force. So that aura that is created by q1, that we call it field. That means this q1 is creating some aura here, and in this part you are putting another charge at the Q2. That means this Q1 we call source charge, and this we call test charge. Separation is R. Then what will happen? You will say very simple that force is equal to 1 by 4 pi epsilon naught Q1 Q2, okay, by R square. We can write like this. Now you will say, sir, why you are putting the bracket here? Yes, I am putting a bracket. There is one region is behind it that you can say here. This is the Q1 Q2. This is like this. This is a force acting on Q2 due to Q1. So this force divided by Q2, if I do it, then what you will get, this force is equal to force divided by Q2, that is equal to 1 by 4 pi epsilon naught Q1 by R square. This quantity we call it electric field. This ratio we call it field, electric field. Electric field created by charge Q1. Created by charge Q1. It is created by charge Q1. Okay, now understand very simply. You can say the field due to charge Q1 is equal to 1 by 4 pi epsilon naught Q1 by R square. It's the very simple thing that I'm writing it. This is the way to write it. This is the field. Okay, another way to write it, this field, how I have written, this field is nothing else forced by charge particles. That I'm writing it Q, I can assume it, or Q0 you can assume it, that I can say this is a field. I'm writing like this. This is a field is equal to F by Q0. We can write it, that we are writing, or F is equal to Q0 into E. We can write like this also. This is the second way to write this. So what we are understanding from this part, these are two lines. We are writing the field is equal to F by Q0, or F is equal to Q0 into E. Understand this line. These two lines are very, very simple line, but very, very important line as a concept. I'm repeating again, E equal to F by Q0, or F is equal to Q0 into E. What is the meaning of this? Akshata, beta, this is actually first topic, first chapter of 12th class. Okay, 12th class first chapter we are discussing that the electric charge and electric field. So charges and Coulomb law we have discussed till now in the last 5 classes, and now in this class we are starting the electric field. Okay, the second part of this chapter. So you can watch those classes also in a YouTube. You can find it in the same channel. You will go and you will find a previous 5 classes, that you will understand. I have started from very scratch, and you will see each and every detail given in the question, and all applications also. Okay, very good. Now understand this part, E equal to F by Q0, or F is equal to Q0 into E. These two lines look like very simple and same also. These two equations, it look like same. It look like same, equal to F by Q0, or F is equal to Q0 by E. But understand, these both lines, both equations are totally different. What's the meaning? I'm telling you. When I'm saying E equal to F by Q0, or F is equal to Q0 by E, meaning is that if I want to write this F is equal to Q0 E, that means already electric field is present. From that electric field, I want to calculate what beta force. What is the meaning? Suppose this is the one charge particle, and there the electric field is present already. External, some other body is creating some electric field. Don't worry about it. What the source of the field? Some source is there. From that source, the field is coming. You are placing this charge particle. Then what is the force acting on this charge particle? I want to calculate. Then you will use this equation. F is equal to Q0 into E. The second equation. What is the field? The field is equal to F0 by Q. That means if I am checking one particle is there, one charge particle is there Q. On that charge particle Q, we are seeing there is a 10 Newton force, 20 Newton force, some F force is acting. We know the force, we know the charge, we don't know the field. Now I want to calculate the field. So what is the field that is the field we can create. We can understand how much field is created by any source. So this field calculation is done by previous equation, and if we know the field, we can calculate the force. These are two simple equations we are writing it. Okay, now understand one very basic thing. When we are writing the field is equal to force by q naught, this q naught is nothing as charge, this is the force, means Newton. So Newton per coulomb, we call it SI unit of this part. This SI unit. What is SI unit, beta? Newton per coulomb. One more unit we will learn with the time in the next chapter, that is the volt per meter also. So don't worry about it. Volt per meter we can write it. Volt per meter, beta, we are writing volt per meter. That also we will learn with the time. Okay, this is the SI unit. Okay, from this we can see very simple, this field is actually what created by source charge. So it is a vector quantity. It is a vector quantity, not a scalar quantity. So we are just writing it as a vector quantity. Okay, now very simple, we are writing it, this is the vector quantity. And we have already seen the few things about this electric force also in the previous classes. You can check. And now I am discussing one by one all this classes. You will see the properties of electric field. What are the meaning of properties of this field? So what are the meaning of field? If we see it, we have seen directly that this field is equal to 1 by 4 pi epsilon naught. Some charge is there and upon r square. We are writing it because suppose their charge is this is a capital Q, this is Q naught, this I am saying source charge, this is a test charge, separation is R, so field would be this. This is the field. So this field is equal to 1 by 4 pi epsilon naught Q by R. Okay, so we can say it is directly proportional to the magnitude of source charge. That means it depends on the Q, capital Q, depend on capital Q. Okay, depend on capital Q, directly proportional to capital Q. Obeys inverse square law. That means it is obeying 1 by r square, similar to the Coulomb's law. Similar to the Coulomb's law, you can see the field is inversely proportional to r square. It obeys inverse square law. Next, medium dependent. Just like the Coulomb's law, also medium dependent. If you change the medium, definitely it is also going to change. What is the meaning of that? I am just repeating again. Suppose there is a charge particle is there. This charge is q at r distance. At this point, I want to write field. So what is the field? You will say field is equal to 1 by 4 pi epsilon naught q by r square beta. This is the field. And similarly, if there is a medium, this is free space. I am writing it is a free space. It is a free space beta. Okay. And if the medium is there, it's the medium. Suppose it's a field, medium is filled here. It's the medium. And this medium dielectric constant is K. Medium dielectric constant is K. And this source charge is Q again. And separation again R. At this point, I want to calculate the field. Then you will say E prime is equal to 1 by 4 pi epsilon naught into K. Because this K is a dielectric constant we have learned. And Q by R square. Or you can see 1 by 4 pi epsilon naught Q by R square is E divided by K. So we can say this is E by K times. That means whenever there is a one dielectric constant is there, then field decreases by K times. Similar to the we have learned if two charged particles present in a medium, then also the field is decrease. The force acting between them also decreases by how much? K times. We have learned the same thing. I am just repeating again. Again here, the field is also decreasing by K times. Try to understand it. Okay. So it is clear to everyone. If it is clear, put your text in the chat box. It is clear to everyone. Amala, Sharanya, Lakshmi, Swati, Navdeep, Akshata. It is clear to everyone, beta. Next point we are going to discuss now. Very good, beta. Sharanya, Lakshmi Priya, Swati, good. Navdeep, very good, beta. Okay, now come to the next point, what I am discussing. The central field. What I am talking about? Central field. This is a central field, just like central force. The electrostatic force, Coulomb's force, we have discussed. Very good, beta Kamala. We have discussed the Coulomb force. That is the central force. Similarly, this is also central force. That means this field is along a line joining, okay, from a certain point, a fixed point. Along that line only this field is going on. So that means this field is also central field. Just like a central force we have seen, so we are seeing the central field. It is also conservative field. Just like conservative force, this field is also conservative in nature. Okay, from that conservative nature only the force become conservative. Next point, it obeys law of superposition. Similar, just like we have seen the Coulomb's law. I will discuss in detail what is the meaning of that principle of superposition. See clearly here. Suppose there are few charge particles. I am just saying at this point. This point is I am saying A point, and these are some charge particles. I am writing it. Suppose this is a Q1 plus Q1. This is a minus Q2. This is a minus Q3. This is a plus Q4, and this is Qn. I am just telling you this is a Qn. Okay, Qn. So I am asking what is the field at A point. What is the field at A point I want to calculate. So how to calculate that field at A point? So that meaning in nothing else, you have to do the vector sum of all individual field. All individual fields. So I am writing it field due to, it is a vector sum of field due to 1, then field due to 2, then field due to 3, then field due to 4, and then field due to n. These are all n particles. From that, if you are individually calculating all field and do the vector sum, then you will get the what? Net field at A. Net field at A. Now you can see what is happening here. The very first thing, due to Q1 beta, due to Q1, the field would be radially outward. So this is another property we are learning now with the time. If the point charge is there, positive charge is there, so from positive charge, field is radially outward. Field is radially outward. Field is radially outward. Try to understand it. This field is radially outward. If it is negative charge, the field is radially inward. Field is radially inward. This is a radially inward. That we are writing it. This is a radially inward. This is radially outward. We can write it. Okay. Next, you can see this negative charge. So from that radially inward, from that also radially inward, from that also radially outward. This is radially outward. This I am saying this is a E1 field. This is E2 field. It is E3 field beta. It is E4 field. We can write, and from that n also this is radially outward at the En field. So these are all fields. We can add all of them vectorly and you will get the net field. That we call principle of superposition, or we can say law of superposition. Definitely I will be available in both. Okay, Amala, I will be available. In Michelle also, I will be available. So you can join. In boys, in missile I will be available, and in girls I think in VAIDYAH program I will be available. So or missile I will be available. It depends. So management decision totally. So you can join, then you will understand. Okay. Now we have to understand the next next property also. What is the property? The independent of presence or absence of test charge particle. That means that I told you that the charge is there, capital Q, source charge, and Q naught is the test charge. So test charge is present or not present, it does not matter. The field will remain same. That means I am creating my field everywhere. If I am a positive, I am a charge particle here, and I am creating field in every direction. But any other charge particle is present here, then it will experience a force. If it is not present, definitely it will not experience any force. Okay, so it another charge particle is present or does not present. I am creating my field. I am taking class. The many students are taking class or they are not taking class. It does not matter. I am taking class. That means I am creating a my field on YouTube. You are there, definitely you will be affected, means you will get some benefit. If you are not taking class, definitely you are not taking benefit. That's the another part. But I'm creating my field. I'm creating my field. The field is present. It depends on source charge. I'm a source right now. So I'm a source. I'm creating my field. If you are listening, if you are attending the class, definitely you will be benefited. That means you are experiencing a force exerted by source. Got it? Clear? This point is clear or not clear, beta? Now, next point we are talking about. It is a vector quantity. We have seen just now. This is a vector quantity. SI unit is a Newton per Coulomb, and another unit also I told you, that is equal to beta volt per meter. Volt per meter, that we have discussed. Next is the electrostatic force is a two-step process. What is the meaning of this? What is the meaning of this? That is a very, very important point. I am just writing. Divik, beta, hello. Now, electrostatic force, it is a two-step process. What is the meaning? Just now I told you, I am creating my class. Just listen carefully. Very, very important point I am just giving it. Any field created by any source, it can be the maximum speed I can create, that is the speed of light. You will say, what is the meaning, sir? I didn't understand. Yes, you have to listen carefully. What I am saying to you and what you are listening, there is a one time gap is there. 1 second or 2 second time gap is there. Okay. What I am saying, you are not exactly same time you are not listening. There is a time gap. Okay. That's why when you are putting the any text, so when I say put your comments, your understanding or not, so that comes after a few seconds to me. You are listening after a few seconds. So there is a time gap. That means what I am saying and what you are replying, there is a time gap is there, because you are getting the information little late. After 1 second or 2 seconds, you are getting that information. So similarly, understand, this is about just analogy. There is no relation with the field. Now listen. Suppose one charged particle is placed here on the earth, the charge Q, and there is another charged particle is present 1 light year away from earth. Another charged particle present 1 light year away from earth, and this second charge want to experience the field due to this charge present on earth. So after how much time it will experience the force? Question is that. So very simple, you have to understand this charge particle you are putting right now, today, if I take the today's date is the 29th May 2025. Listen carefully what I am saying. If this date is 29th May, okay, 2025, that means the second charge will experience the force after exactly 1 year. That means 29th of May 2026. It will experience the force. 1 light year, that means its field will take a time of 1 year to reach up to that charged particle. It will take 1 year time. It will take 1 year time. Then only that second charge will experience a force. Not right now. Not today. It cannot experience any force. So Coulomb's law, if I say, don't go into too much detail. What I am telling you, it is not up to the 12th level. Just for understanding, I am telling you what is the meaning of this two-step process. Just listen carefully. So when I am saying the charged particle right now, here you are putting it. So whatever you are putting right now here, the another charge 1 light year away from the earth, it will not experience the force right now. It will experience the force after 1 year, because you are doing any change here. That is that charged particle cannot understand that part. That information will go after 1 year, because any information can travel up to the maximum speed of light. It is given by Einstein's very beautiful theory that we call special theory of relativity. That means this information can pass by the speed of light from one place to another place in the form of electric field. To try to understand, if you are doing any change here, it will not experience by the another charge particle at the same moment. After some time it will experience. So what is happening? Listen carefully. First, there is the one source charge. It is creating its own field, and that field is exerting a force on the test charge particle. I'm repeating again. First, the source charge creating its own field, and this field is exerting force on the test charge particle. So force is not directly applied by the source charge. It is a two-step process. First, this source charge creating its own field, and this field is exerting a force on source charge. So it's a two-step process. Now I think it is clear to everyone. If it is clear, please reply. Amala, Navdeep, Vivek, Saranya, Swati, Lakshmi, Akshata. It is clear to everyone. If it is clear, please reply beta. Very good beta. Purna, Swati, Ravi, Navdeep, Sharanya. Very good beta. Amara, very good. Now we are going to study very simple question. I am taking it, and then we will understand how to calculate the electric field. So we know this is a vector quantity, not a scalar. So we have to take care of vectors. To try to understand, we have to take care of vectors. So we already know the few things. I'm just again revising the few things that you have to learn it. You have to understand it. Now, very basic thing is, suppose there's a one triangle is there, beta. If I say this is an equilateral triangle, and this charge is Q, this is also Q, side length is L. Side length is L, beta. At the side length is L. This point is, I'm saying A, and at A point I'm just asking what is the field. Calculate the field at A. Calculate the field at A. That's the one of the corner of a polygon. So I'm taking equilateral triangle first, very basic polygon. Now you can tell. So due to there are actually 2 point charges Q1 and Q2. So due to this B charge, so due to this field would be radially outward, because I am taking both are positive. These are both are positive. Don't worry about it. So the field would be outward. Suppose I am saying this field is E. So similarly, due to C also, the field would be outward, because this is also positive. The field would be outward. Because this charge is same, the distance also the same. That means this field is also same. So this is E. This is also E. I am writing it. So using this E and E, so you will find that the resultant would be here. That I am writing it E net. What I am saying, E net. We have to calculate. This angle is 60 degree beta. So we know already this is angle also 60 degree. You can find the E net. So what is the value of E? E you can say that is equal to, sir, K Q upon this distance is L square. So you can write L square. This is the field. And what are the angles? 60 degree. So you can say E net is equal to under root of E square beta plus E square plus 2 times of E into cos 60 degree. If you are saying cos 60, that is a 1 by 2. 1 by 2 and 2 is cancelled. E square plus E square plus E square. Total become 3E square. That means we can say root 3 times of E. Or we can say root 3 times of K into Q by L square, that is equal to E net. This is the net field at this one corner. Clear beta? Yes sir, no sir? Hi, good evening beta Neelam. And Navdeep, sir, there is any charge at, please, if I'm not understanding. Okay, Purna beta, I will change the color. I will not use this red color now. Okay, I'm sorry for that. But for now, just try to Understand? Okay, brightness increase. Okay, you can increase your brightness in your mobile or tab or laptop, whatever you are using it. Purna beta, and further I will not use the red color. Don't worry. Now come to the another question. I am taking the same. Suppose this equilateral triangle only there. It is the equilateral triangle. Okay, and this charge is plus q. This charge is now minus q, not plus q. This distance is L, L, L. Again, I am taking this point is suppose A beta. Again, I am saying this point is A, and question remains same. Find the net field at A. Net field at A. How to calculate? So very simple. Due to this, this point is B, this point is C. Due to B point, what is the field? Field would be radially outward. That I am saying suppose E. Okay, but due to C point, what will happen? The field would be radially inward. This is the radially inward. That is the E. We know already this equilateral triangle, that means this is 60 degree. That means this outside angle would be 120 degree. It's the 120 degree. So E net would be somewhere here. We can see this is somewhere here, that we can say that the E net. Now we have to calculate this E net value. So again you will say, sir, E is equal to, we know the K Q by L square. Again I want to calculate E net. E net would be how much beta? E net would be under root of E square plus E square plus 2 times of E into cos of 120 degree. Cos 120 is minus 1 by 2. Okay beta, minus 1 by 2, that would be how much? E square plus E square beta. Okay, plus 2E square into minus 1 by 2. Minus 1 by 2, 2 cancel, this become minus E square plus E square cancel, this is E square only. That means this is a E only. That means E net is equal to E. That means K Q by L square. That is the answer. This is the field at one of the corner. It is clear to everyone beta? No beta. Amala, there is no charge present at Q. At A, no charge is present. No charge present beta. I told you already कि when we are calculating field, it does not require any test charge particle. Present, good. If not present, then also good. Got it beta? This is a very simple that we saying the E net is equal to E KQ by L square. KQ by L square we can write it. Very, very simple thing, very basic calculation we can do it. Now, suppose it is not like this situation. Another situation I am just giving you, please understand. Okay, this is the equilateral triangle. Again, I am taking equilateral triangle. This charge present is Q. It is also present Q, and I am taking very simple case. This is also Q. Thread length L, L, and L. Okay, and I am asking one point. I am taking a one point here. You can choose this color. Okay, suppose this is a center point. I am taking this point is O. So what is the field at O? That's the question. What is the electric field at O? Can we calculate? If we can calculate, just I am waiting for your answer. Please reply. What was the field at O? What is the electric field at O? Please reply beta. Please reply. And I understand one thing what I am telling you for your preparation for this NEET. When you are preparing for it, the most important thing is when you are studying physics, take pen and paper, try to solve the things. Understand the concept. Unless your pen is not working, your paper on the paper, when you are not writing in the paper, it question paper in the final test exam, it is very difficult to get the answer. Understand my words, what I am telling you. In the recent paper also, questions were not like that. Without solving you will get the answer. You have to solve. So you should make a habit to take pen and paper and to solve it. When you solve it, definitely you will get the answer. Many students putting their answer. Very good. Okay. Sharanya, very good. Lakshmi, Yamini, Swati, Neelam, Tarun, very good, beta. Vivek, beta, I will say if you are taking the Sri Chaitanya module, that's the one of the finest modules, you will find it. You can follow that. Tarun, beta, very good, beta. Your answer is 0. Okay, correct. This answer would be 0 because all distances are equal and all fields are also equal. Navdeep, very good, beta. Correct answer. So you can follow that module, and there are some standard books also are in the market. The very first, very important book is NCERT. Without NCERT, nothing is there. So follow NCERT, one thing. And the second is the NCERT exemplar, especially its objective one. And try to learn very short answers questions also. If you can solve them, then definitely it will help you out. So short answer questions and objective one at least you should learn. And if you can understand the concept of objective 2, maybe you are not able to solve, then you can take the help of their answer key or solutions or teachers help. You can take it, Divik, then also it will help you out to understand the concept. Very important. Now come to this point. Definitely these all distances are equal. We can calculate this distance also. I am taking a small r. This is a small r. By the way, this small r value is nothing else. You can say L by root 3. Okay, L by root 3. You can put it. I can say this is a root 3 by 2L, and yes, this is a R is equal to L by root 3. You can put it, and the field would be at a O point. That would be very simple. There all fields value is same. All field values same. Due to plus Q, that would be like this situation, and due to this plus Q, that would be like this situation, and due to this plus Q also like this situation. So they are balancing each other, so that would be 0. Net field would be 0. So E net is equal to 0. E net is equal to 0. Very basic. Not only in this triangle case, you can take any case, suppose this is the one square is there. In the square also, if you are putting plus Q charge, Q charge, Q charge and Q charge, if you are asking at the center, then also field would be 0. You can take it. Similarly, you are taking, suppose a regular hexagon is there. It is a regular hexagon. Then also you will get the answer. At the center also it is 0. At the center, suppose these are charge Q, 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 Q and Q, and this is also Q. Then also center at the field would be 0. Try to understand it. Clear? Now basic thing I am just telling you how to calculate the field. There will be 0 here. There is no problem about it. But if I say here another question, there is a one pentagon, then also answer would be 0. If the pentagon is there, please understand the concept. It's the pentagon. If I am talking about at center, these charges are all charges given to you, Q, and all sides also equal. I am saying regular pentagon actually. So this is symmetric situation. At this center, field would be again 0. Field at O is equal to 0. No problem. So any polygon, n-side polygon, you are taking it. Not only this, any n-side polygon you will take, that answer would be 0. Even it's a circle also. Suppose this is a circle, and on circle if you assume this is a charge, circle means ring, you can take it. So at the ring, if I ask you at the center, what is if this radius is r beta, charge is q, total charge is q, uniformly distributed. Uniformly distributed. So what the center at field? Then field is also center at would be 0. So try to understand it. Field at center would be 0. So this concept is clear to everyone. Okay. You can take in place of positive charge. In place of positive charge, you can take negative also. The answer would be same. That is 0. Nothing is there. Okay, beta. It is clear to you or not clear, beta? This all concept. Just tell me. It is clear or not clear? Now, if it is clear, then I will tell you the few more things, beta. Neelam, Divik, Tarun, Sweta, Navdeep, clear, beta? Saranya, very good. It is clear to everyone? Okay. Now try to understand it. Not only this, now I am putting the same concept what we have learned in the Coulomb's law. Directly you can apply, you will get the answer. You will tell me now. If I say to you here, this is about equilateral triangle. This charge is Q, this charge is Q, and this is center at O. And this distance is R, beta. This distance I am saying R. No need to calculate. Already I have given to you. What is the equilateral triangle? Side L, L, L. Now question is that what is the field at O? Now try to understand at this point above top what is it? There is no charge. Try to see. Now this question is there. Find the field at O. Can you calculate? First question I am giving you. Try it. The second question already we have seen how to calculate it. Okay. Next, second question I am giving to you. Suppose this is the one square is there, beta. Okay. This is a Q. This is Q. This is Q. And this charge is missing here. If you go for this, if you join it like this is center, and this side is L, 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 L. By the way, I am saying this is R. You know already what is the value of R. I am writing R is equal to L by root 3 beta here. Don't worry about it. If you see here, that is what is the value of R? That is equal to L by root 2 value beta. Don't worry about these values. How much value I have given to you. Now question is that what is the field at O? This is the field at O. I am asking here what is the field at O. Okay, what is the field at O? And if I ask you the direction also, you can tell the direction also. It is very simple. This is A point, this is B point, this is C point. Here also I am putting this point. This is A, this is B beta, this is C, this is D. What is the field? Please try to solve these two questions. If you are able to solve this question, definitely we will see some more thing. Vivek, okay. Amala, you are getting some answer. Okay, we will see. Tarun, Swati, Sharanya, Navdeep, Purna, please try and tell me the answer. I am giving a 1 minute time. Until unless you are solving, that is very difficult in the final paper to solve. So very important thing is to understand the concept and take the pen and paper and try to solve the question. Tarun. We will see, beta. Okay. Now I am telling you. All students, at least they tried. Devik, your answer is correct. And others' answer is wrong. Definitely your answer is wrong. Okay. Now, how to solve this question? If you have attended my classes, we have seen, we have discussed in very much detail. I will show you if I am having in this PPT only those questions. I will try to see. Just wait. If I am having, definitely I will show you. Just this question. We have discussed this part, and I told you also very important thing here. If you are understanding this question, see these questions we have done here. Already we have done. If now question was there ki one charge is missing. If I am removing this charge Q, if I remove it, if I am removing this, removed, if we have removed this charge, then what was happening? We are writing the net force at the center is equal to 0 if all are present, but if this charge is removed, then what you are saying, the Fa plus Fp plus Fc is equal to minus Fd, and that Fd is equal to kqq by a square. Very simple. That is the force due to the one particle, one charge only. This is a removed charge only, because that is equal to Fd only, and Fd answer you already know. Same thing we have done for regular hexagon also. In regular hexagon also, this is q present. This is not present. We assumed it. That means this is removed charge. But that means if all are present, all 6 are present, the net force would be 0 at the center charge. But we want to calculate due to only 5 charges, then that is equal to minus of this sixth removed charge. Due to this 6th removed charge, that means that is equal to minus ff. Then we have seen that kqq by a square. That means due to only this removed charge only. That is the answer. That means we have to focus only whatever the removed. So same thing we are going to do here also. If you are seeing here, you will get the same answer. Same. I am just writing it. Then you will understand it. What you will say, beta? You will say very simple thing here. The field at A. If you are putting here, if one charge is also present, by the way, it is not present here. It is not present. You are putting just to understand the concept. What you will say? You will say it's a field at O would be fold due to A plus field due to B plus field due to C is equal to 0. If you are adding all 3 charges are present, then it is equal to 0. That means what is the field due to B plus C? What is that value? That is equal to minus of field due to A. This is the concept that we have to learn. And field due to A is nothing else. What is that value? Because this distance also R. So directly you will say that is equal to K Q by R square. That is equal to field due to A. And you can tell the direction also. The field due to A direction is what, beta? If it is positive, that means this direction, AO direction. But we want to see negative of EA, that means you can say field due to B plus field due to C is equal to negative of this A direction, A field, that means KQ by R square. And what direction? This was AO direction, that means this is the AO direction. But this negative sign means opposite direction, we have to put it. Got it? Similarly here also. This charge is not present at A. You are assuming this charge from your side. It is not given. That means what is the answer now? Again you will do the same thing here. Again you have to do the same thing, beta. What you will say? Field due to A plus field due to B plus field due to C plus field due to D is equal to 0. If it is equal to 0, but we want to calculate due to these 3. So what you can say? Field due to B plus field due to C. Sorry, beta. This is field due to C plus field due to D is equal to minus of field due to A. So this thing you have to calculate. And this already you value given to you, that field due to A is nothing else K Q by R square, and due to A this direction would be in this direction, that means AO direction. It's the AO direction, but we want negative of this. That means here you can say the field due to B plus field due to C plus field due to D is equal to field at O. By the way, that is equal to minus of KQ by R square and AO direction. It is clear? Mohit, Navdeep, Charanya, Tarun, Amala, Navdeep, Lakshmi, Swati, it is clear? Yes or no? Are you understanding what I am telling you? Please reply. Please reply, beta. Sharanya, very good, beta. Other people also please reply. Now I am asking very basic question, you will answer it. Tell me, beta, field at O. There should be no mistake now. Devik, beta, it's just starting. Till now we have not put any integration differentiation. Okay? It is just starting of physics. Don't think any complexity. This is a very basic. Try to understand. If you understand it, tomorrow I will show you some questions. Some good questions, definitely. It is just basic, I am just telling you. Now, good. Now it is clear to everyone. Now this question, that is equal to what value, beta? Navdeep, your answer is correct. Devik, good. Other people also please reply. Saranya, Tarun, Swati. What is the answer? Lakshmi Priya, very good, beta. Good, correct answer. Directly you can say the field at O would be due to this remaining charge. What is removed charge from here? The removed charge, this is Q. That is the removed charge. So you will say, sir, this is a KQ by R square negative sign. But this field would be in this direction, that means AO direction. And opposite to this would be the field. Clear or not clear? Directly you can say this line. Yes or no? Clear, beta? To everyone? This concept is clear to everyone? Very good, beta. Now, the very important concept of electrostats I am going to discuss, that we call it null point. The null point is a point at which the net electric field is equal to 0. The point at which net electric field is equal to 0. Net electric field is equal to 0, okay, is known as null point. Is known as null point. This is the definition of null point. The null point means the point at which the net field is equal to 0. I am just giving you two cases. Case 1, beta. There are two charges. This charge is a Q1, I am taking it. This is a Q2. By the way, both are positive, I am taking it. For simplicity, I am taking both are positive. Okay, both are positive. So where the field would be 0? The very first thing you have to understand, the field would be 0 along this line only. Along this line only, there will be some point at which the field can be 0. But any other point, it cannot be possible. Now you will say, sir, why? I will give you some examples. Don't worry about it. If you see here, I am taking the few cases. Suppose there are the few regions. Few regions I am taking. Region 1, region 2, this is region 3. There are 3 regions. Any point you can take. Any point you can take. Suppose you are taking the point here. This point is A. Or you are taking any point here, B. Or you are taking any point here, C. Now you can check at these 3 points where the field can be 0. Where it can be possible. Now see, due to this plus Q1, at A, the field would be radially outward, means outward direction. This is the field. Due to C also, this would be outward direction. It is outward direction. It is outward direction. So both are added. Both are added outward. If you see at C point, due to Q1 also outward direction, due to Q2 also outward direction. So both are added. That means they are not cancelling each other. They are supporting each other. They are added. But if you see at B, due to Q1, that would be radially outward, means right side. But due to Q2, this will be also radially outward, but this is left side. This is field due to Q1 means 1. This is field due to Q2, that means 2. This is field due to 1. This is field due to 2. That means at B point only, null point is possible. At B point only, null point is possible. At A, it is not possible. That means region 1 not possible. Region 3 not possible. Region 2, there would be some point where the null point is possible. So what you understood, when the two like charges, either they are both are positive or both are negative, then null point will lie on the line joining 2 point charges at between them, not outside, between them, if both are positive or both are negative. So I am taking this point. So at this point we have to calculate very basic thing. So I am taking this distance. Suppose this distance is here to here, that is x, and total separation was, I am taking suppose d. I want to calculate x, that is the position of null point. So I am just calculating it. So you will say, beta, due to Q1, what will be the value? Field, that means E1 is equal to E2. So what you will say, E1, that is equal to K Q1 by x square. Due to Q2, K Q2 by how much distance, beta? If you see this distance, if I say here to here, this distance would be, beta, d minus x. So you will say directly, this is d minus x whole square. You can write it, d minus x whole square. You can put it, you will understand. K is cancelled from both sides. I am writing this d minus x whole square upon x square is equal to Q2 by Q1. You can take the root. This becomes d by minus x divided by x, or you can say d by x minus 1 is equal to root Q2 by Q1. You can write like this, or this is a d by x is equal to root over Q2 by Q1 plus 1. You are interested in x, so x would be d divided by under root of Q2 by Q1, okay, plus 1. That would be the what? Position of null point. Directly also you can remember it. Remember, this is the position of null point if both are positive or both are negative, and we have measured this position from Q1 side. Try to understand it. From Q1 I am measuring this distance. Okay, and giving you one question for you for your as a homework. Try it. We will see in the next class. If there are not both are positive, suppose this is one is positive charge and one is negative charge. Suppose I am saying this is a Q1 negative and Q2 is positive. The distance is R. Okay, or D, you can say this is distance is D, and I am giving you Q1 magnitude is less than Q2 magnitude. It is given to you. Now question 8, find the position of null point, and I am saying it will lie this side okay, at some distance x. I'm giving you a hint, and this value will come, that is equal to d by under root of q2 by q1 minus 1. This is your homework to prove it. Get the correct answer what I have written, and this would be lie in the smaller charge only. This is your homework to prove it is correct. If you are not able to solve, definitely in the next class I will discuss. Okay, so today I am keeping class up to here. I think it is understandable for everyone. If it is a useful class for you, please like the class and share with your friends, your classmates, and thank you so much. Enjoy your evening, and you can attend the next class. Thank you beta. Bye bye.